One strategy for solving exponential equations is to rewrite the equation so the bases are the same on both sides of the equation. If the bases are the same, then the exponents must also be equal. Let's look at some examples. Starting simple, if we have 3 to the power of x is equal to 9, we have a base of 3 on the left-hand side of our equation, and we can rewrite 9 as a base of 3 with an exponent of 2. So we could rewrite this equation as 3 to the power of x is equal to 3 to the power of 2. Because we have an equation now where the bases are the same on each side, the only way that these can be equal is if the exponents are also equal, so x must be equal to 2. Let's try again. If we have 5 to the power of 2x plus 1 is equal to 125, we have a base of 5 on the left-hand side. 125 we can rewrite as 5 to the third power. So this equation becomes 5 to the 2x plus 1 is equal to 5 to the third power. Since the bases are the same, the exponents must be equal, so we can rewrite the equation that 2x plus 1 must be equal to 3. Solving for x, we can subtract 1, so 2x is equal to 2, therefore x must be equal to 1. A couple of things to watch for on these. As we see in part C, we have 3 times 2 to the x plus 1 power equals 24. Be careful not to multiply the 3 times 2. So you cannot multiply a leading coefficient out in front times a base. But what we can do is divide both sides by 3 to isolate 2 to the power of x plus 1. 24 divided by 3 is equal to 8. And now we can rewrite 8 as 2 to the third power. So 2 to the x plus 1 is equal to 2 to the third power. For this to be true, x plus 1 must be equal to 3, so we have that x is equal to 2. Looking at one last example here in part D, the thing that is different here is we have exponents on both sides of our equation. So we have 5 to the power of 6x plus 10 is equal to 25 to the power of x minus 1. So when we see the 5 and the 25, we want to think about a common base of 5. So the left-hand side is going to stay the same. On the right-hand side, I'm going to think of 25 as 5 squared to the power of x minus 1. When you have a power raised to another power, we're going to multiply those exponents together. So this becomes 5 to the 6x plus 10 is equal to 5 to the 2x minus 2. So a power raised to another power, those exponents are multiplied together. Then set your exponents equal to one another. So 6x plus 10 must be equal to 2x minus 2. So solving for x, we can subtract 2x on both sides. I'm going to go ahead and subtract 10 at the same time. So 6x minus 2x, we have 4x, negative 2, take away 10, we have negative 12, so dividing x is equal to negative 3. So one strategy for solving exponential equations is to rewrite the equation so that you have the same base on each side of the equation, and if the bases are the same, then the exponents must also be equal, allowing us to write an equation where we can solve for a variable that's in the exponent.